been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, this video is about proving theorems about perpendicular lines. It comes from section 3.6 of the book. So we're going to look at these theorems, which you need to have in your notes. So if you want to copy down these couple theorems first, and then I'm going to explain what they mean and draw a picture to illustrate it. So theorem 3.8 says, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So a linear pair, remember, are two angles that are adjacent and supplementary. They have opposite rays. So if these are the two angles, angle 1 and angle 2, that are the linear pair, and they're congruent, which means angle 1 is equal to angle 2, then what does that mean? Well, it means they must both be 90, which means that the lines are perpendicular. So this is line G and this is line H. So if angle 1 is congruent to angle 2 and they're a linear pair, then those lines are perpendicular. If two lines are perpendicular, so I'm going to draw that. Two lines are perpendicular, then they intersect to form four right angles. So we know two perpendicular lines intersect to form a right angle. Well, if this is a right angle, then so is this, and so is this, and so is that. So you have four right angles there, angle 1, 2, 3, and 4. This is line A, and this is line B. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Two sides of two adjacent acute angles are perpendicular. So, for example, I have adjacent angles here, and this side is perpendicular to this side. Then that means this is a right angle, and those are acute angles. Then the angles are complementary, which means angle 1 plus angle 2 add up to 90. Measure of angle 1 plus measure of angle 2 equals 90 degrees. Because this and this are perpendicular, which means they form a right angle. If a transversal is perpendicular to one of two parallel lines, so I'm going to draw parallel lines here. So it says if H is parallel to K, so here's H and here's K, and J is perpendicular to H, so here's J. And I'm going to show J is perpendicular to H like this with a right angle. Then J is also perpendicular to K. And we could think about that using what we know about parallel lines and a transversal. If we know that this is 90, we know this is 90. And we know this is 90 because why? Because angle, if I call this 1, and I call this 2, and I call this 3. Angle 2 and angle 3 are alternate interior angles, which we have a theorem that says those are congruent if the lines are parallel. And so if this is a right angle, then that must mean that J is perpendicular to K. Lines perpendicular to a transversal. So in a plane, if two lines are perpendicular to the same line. So I have two lines here, and they are both perpendicular to this line. So that means this is a right angle and this is a right angle. Then they are parallel. So what's given is that M is perpendicular to P, so this is M and this is P, and N is perpendicular to P. Then we know that M is parallel to N. And again, we could think about that through what we know about parallel lines and transversals, talking about corresponding angles, which, by the way, angle 1 and angle 2 are corresponding angles, which if the lines are parallel, cut by a transversal, then corresponding angles should be congruent. Okay, now we're going to talk about the distance, and when I say distance, what do I mean? So the distance from a point to a line is the length of the perpendicular segment from the point to the line. So I'm going to show you what I mean by this. Okay, so we need to figure out the distance from point A to the line that I drew. We're going to call that line N. So we need a perpendicular segment, which means we need a perpendicular line from A through A that's perpendicular to line N. So first we need to know the slope of line N. The slope of line N is up 1, 2, 3 over 1. So that's a positive 3/1, which is the same as 3. So the perpendicular slope to that is going to be negative 1/3. Negative 1/3. So from my point A, I need to make a line that has a slope of negative 1/3. So I'm going to go down 1/3, which lands me here, down 1/3, down 1/3. So there is my perpendicular line. Now, if I'm trying to find the distance from A to the line, then I actually only need the distance of this segment right here. Well, it looks like I have 2 points, so I can use my distance formula. So my one point is negative 1,4. My other point is 2, 3, which again is this intersection right here of those two segments, or the segment and the line. So I'm going to use my distance formula. y2 is 3 minus y1 is 4 squared plus x2, which is 2 minus negative 1 squared. And I'm going to call this point B, and so I'm finding the distance of AB. So AB equals the square root of 3 minus 4 is negative 1 squared, plus 2 minus negative 1 is actually 2 plus 1, which is 3 squared, which is going to be negative 1 squared is 1, 3 squared is 9, so it's going to be the square root of 10. The square root of 10 cannot be simplified, so this would be your answer. If for some reason it asks you to round, then you would plug that into your calculator and you would figure out what the decimal answer would be. But this is the exact answer. When I say exact answer, then I do not want you to be rounding anything. Make sure we understand what that means when I say exact. So if you need to find the distance between two things, we should know that the distance between two things is always a straight line. And so when we say straight, we really mean perpendicular, okay? So if you're trying to find the distance between two things, make sure you've got a perpendicular segment there. Make sure you understand what a perpendicular slope is.
I've been waiting way too long. Yeah.